Okay, we're looking at the mechanism question from the quiz number 2 from spring of 2019 for Organic Chemistry 2. And if we take a look, it's asking us just to propose a mechanism to get from our reactants to our products here. And so let's start to work through this here. For the moment, we'll just abbreviate sulfuric acid as H plus as a proton source. Right, so proton source. Alcohol is going to reach out, grab that proton. That'll be the first productive step, I guess we can say. So at the end, we've got this. All right. Okay. So kind of following up with what I was chatting about in the first video for this quiz, kind of one of the themes for chapter 11 is, taking an alcohol and turning it into a good leaving group. And we do that by either protonating it or reacting it with a Lewis acid that's going to, basically end up with a positive formal charge on that oxygen, which is going to generate a good leaving group, right? Let's do green. That seems okay, right? So that green carbon right there, right? That green carbon that's attached to that oxygen is a primary carbon, right? So if we make that water molecule leave, right? If we make our water molecule leave, right, we're going to leave behind a positively charged carbocation, which probably isn't going to happen in this case, right? It's very, very, very rare for a positive carbocation to form. So much more likely what we're going to do, right, is something along these lines here, where we're going to end up breaking that bond and sending a lone pair out here, right? So breaking that bond, sending a lone pair out there. And I'm going to mark that carbon right there in red, and we'll talk about why in just a second, right? Okay, so let's see if we can follow this set of arrows. So we have our oxygen. It's sent a bond in purple to our green carbon right there, right? That green carbon is bound to the carbon in red. Okay. And then we can wrap up the other side here, right? Let's mark in blue, right? We had 1, 2, 3 other carbons here, right? So 1, 2, 3 other carbons right there. Now, I'm doing this stuff in color. If I were working this on an exam, let me just step a brief aside here. If I was working this on an exam, I would number my carbons, right? I would number my carbons and I would number my oxygen that was involved in that mechanistic step. Okay? But you can use color, when you can. Numbering is just fine. And I just realized I left off an arrow, right? There it is. Okay, that was the whole point of this. So, right, we're kicking off that water molecule. But we're still not quite done yet, right? We're still not quite done because we're leaving behind a positive charge. Okay? So the red carbon there is where the bond was broken, right? I'm just going to put a little star right there, right? That arrow that we drew right there indicates that we're breaking a bond to that red carbon, right? So we better leave behind a positive charge there. Now, there's two approaches you can take once we get to this point. We could rearrange that carbocation to get to our green carbon, right? We could rearrange our carbocation to get over there. And that would likely be a possible thing that happens. That wouldn't be a more stable carbocation. But for argument's sake, we don't necessarily have to show that. Right? So we'll just finish up this mechanism then. Something's going to come in. We'll use water in this case, so let's get our buddy water back. This could be a water that got kicked off. It could be another alcohol, right? It could be another equivalent of this alcohol. It could be the conjugate base here. It could be some water that got kicked off, right? Something comes in, right? Something comes in. Something comes in. It's going to grab that hydrogen, and that's going to fall down into a double bond. Right, so at the end of the day, we've got that right there. All right, not too bad. Couple of, or really one or two tricky parts right here, right? Certainly this part and this part, right, might be a little bit tricky, but nothing unusual that we haven't seen before, right? Sulfuric acid acting like an acid and protonating an alcohol, and then something kicking off a protonated alcohol because it's a good leaving group, and then kind of touching things up there at the end. So I'm going to zoom out so you guys can see the whole thing if you want. And there's our working through of the quiz number 2.